let's try an example on graphing using the vertex form of the quadratic equation. So in this case, we're trying to graph y equals 3 times quantity x minus 4 quantity squared plus 1. In order to do this, we're first going to have to graph y equals 3 times x squared to make it a little bit easier. So this is the full step process explanation. So be aware of that, okay? So once again, our general format, y equals a. A is our typical value. In this case, we notice that our a is 3, right? And we have a negative 4 for our value inside the parentheses, and a plus 1 on the outside on the right side of our parentheses, right? Okay, so once again, our a value in this case is 3, so let's realize that. So therefore, we're going to be using to graph, once again, y equals 3x squared because our a value is 3 for this case. So let's build a table, just like you would for any other type of graph. Building a table real quick. And we're going to just randomly select points. I wouldn't recommend it though in most cases. In most cases, I would actually recommend that you use your calculator, turn on your calculator, clear anything you might have, go to y equals and clear anything that you might have. And then just graphing to take a quick look at what it looks like, and from there select values that would make sense for plotting. But for this case, I'll just randomly select and let you visualize how much of a difference it could make, okay? So once again, just randomly selecting values. Let's say I use -2, -1, 0, 1, 2 as a reference, okay? So those are the values that I'm using for this particular case. And that implies I'm going to use once again the equation y equals 3 times x squared. So let me build the table real quick since I'm going to be using it and plugging in for several values. In most cases, I recommend you show at least one calculation and the rest you can come up with a calculator table. So basically I would go to second graph and then I get a table. And from there I'll copy the values. Once again, but this is for the final value, okay? Not necessarily the y equals 3x squared value. So y equals 3, and then we're substituting the first case scenario. Highly recommend you put parentheses around the x. Remember, there's a square on it. So that means you're doubling it. In other words, you have double negatives. Negative times negative, positive. So -2 times -2 gives us positive 4. So 3 times 4, right? Or operations to apply. Be aware that you got to do exponents first before you do multiplication. So now we can do multiplication. 3 times 4, 12. Okay, so good so far. Going for the next case scenario, let's circle our current solution. So that's why I have a dash for the current solution. And going for the next case scenario, y equals 3 times our next value that we chose, -1. So remember, parentheses, otherwise it would come up to be a negative by accident. -1 times -1, well, that's positive 1, right? Negative times negative is a positive. Okay, therefore 3 times 1 gives us 3. Once again, I'll circle my current value solution. That way I can come back to it and just plot it a little bit more easily in my table there. Next case value that we picked, the 0. Oh, had a -0 by accident, but it's still 0, agreed? 0 is a neutral number. So 3 times 0, well, gotta do the square first. 0 squared, 0 times 0 is still 0. And then 3 times 0, still 0. So y equals 0 in this case. Okay, going for the next case, when we have an x value of 1. 3 times 1, whoops, have to do the exponent first, right? So 1 times 1. 1 squared, 1 times 1 is 1. 3 times 1 is 3. Okay, going for the next one, or the last one for this particular case. 2 squared, 2 times 2 is 4. So 3 times 4 is 12. And finally, we can fill it in on our table. So there's our table. We filled it in on our table. And once again, we're starting and we're going to graph y equals 3x squared. Just a basic form of it. So let's label our x and y axis and do our plotting. So notice that -2 and 12 does not fit in my graph, right? I accidentally chose the number that wouldn't fit. Hence the reason why I recommend in many cases if you're able to, graph it on your calculator to get a visual. At least you get an idea of what numbers you can use for the x value and then plug them into your table. Okay, there's our next coordinate point, 0, 0, and finally 1, 3, and once again I can't fit the +2 and the 12 because it'll be way outside of our graph region, okay? So in that case, let's draw a line of best fits, or another draw a parabola connecting our dots. And I took a rough estimate of what it would look like if I had my 12 or negative 2, 12 and positive 2 and 12 on there. Sort of a rough idea for you, okay? Let's do realize. In this case, our vertex is in the form of h comma k, agreed? So h comma k is our vertex. So 4 and 1 is our vertex values. Notice, you got to use the opposite value of what you have there. In this case, in my equation, I have a 4, which is a negative. My vertex uses the opposite sign, which would be a positive. If it was a positive in my formula, then I would make it a negative in my coordinate. My k value is always the same as the equation, positive or negative, depending on what the equation shows. But my h value is the one that is the opposite sign from my formula. So 4 comma 1 is our vertex, once again positive 4. In this case, it's opposite sign, right? And let's realize that we have our 4 implies that it either goes left or right, depending on the case. If it's positive, you go to the right, negative, you go to the left. And our k value, if it's positive, you move it up. If it's negative, you move it down. So now let's try moving the graph 4 units to the right and 1 unit to the left. Whoopsie, sort of a mistake on my part. Be careful with those, right? I know it's kind of confusing. Now let's get a little bit more straightforward. Let's see, my 4 value, that is my x value. My x value moves it 4 units to the right because it's positive in my coordinate value form. But on the other hand, my 1 indicates whether it moves up or down. That's my y value, right? So it shifts it up or down, not left or right. So once again, be careful with that. I know it can be confusing, but try to review a little bit, right? X value moves it left and right. Y value moves it up or down. Agreed? Hopefully that makes it easier to visualize for you. Okay, so in that case, let's start out with our coordinate, bottom coordinate, and let's shift it to the right 4 units, and we're going to shift it up 1 unit. There it is. There's our final location for our fully graph of the equation y equals 3 times quantity x minus 4 quantity squared plus 1. In other words, the one that we really wanted to graph. So we're just using the red graph as an example or as a reference to get the correct location. Why would I ever use this? Well, the only reason I would use this if I didn't have a calculator available. Don't have a calculator available, I can graph this by hand and then shift it out to make it easier to plot in many cases. Okay, so there is my other coordinate. I'll shift it out 4 units to the right and 1 unit up. There's my final location for that coordinate. 4 units to the right and 1 unit up. And there it is. There is what my graph would actually look like. Once again, if I had my graph, I can always shift my entire graph if I have the ability to. In this case, I can instead of shifting dots. But for you, it might be dots that you shift and draw a line over it. But since I can draw a line, shift it to the right 4 units, and I can shift it up 1 unit. And there it is. I can visually see that I have the correct graph now. So this is, once again, just a way of using your regular graph or your regular equation, basic, when you have ax squared, to graph a more complex graph by hand. So there is once again our vertex, 4 comma 1. Keep in mind, 4, the x value, moves it left or right, and the 1, since it's a y value, moves it up or down.